thing is molecular formula of a compound. Now, what is the molecular formula of a compound? Simple compounds and compound ions. Okay, so what are simple ions? Which shows simple metal ions, simple non-metal ions, and compound ions. So let's understand how do we name these compounds. Okay, so first and foremost, that if you have any compound wherein hello and welcome students. So this is going to be your second lecture of stoichiometry. If you haven't watched the first part yet, then please go and check that out. It is really going to be helpful for this second part. And please show your appreciation by sharing this video with your friends and family, liking the video, and then subscribing to our channel. So let's quickly begin. So in this particular video, we are going to talk about two important topics of stoichiometry, which is constructing word equation and symbol equations, including state symbols. Okay, these are going to be your ABC for the upcoming videos, and make sure you are taking time out, you have your notes with you and your pen with you so that you can note down all the important things. So let's quickly begin. Next, let's move on to chemical equation for the reaction. Okay, so now this is very important. How do we write chemical reaction? There are three main important things. One is reactants. Reactants are the species which react together to form any compound, okay, or to produce any compound, right? So and the compound which is formed after reaction, that is known as product. Okay, then what is word equation? Word equation, a summary of a chemical reaction using the chemical names of the reactant and product. For example, if I have to write the word equation for the formation of water, then what do I write? Water is formed by hydrogen and oxygen. So I will simply write hydrogen plus oxygen forms water. Okay, not H2O, but I will write it in word form. So it will form water. Okay, so this is how we will write a word equation, right? For example, I ask you to write a word equation for the formation of nitrogen dioxide. So what will you write? Nitrogen plus oxygen and then an arrow which shows that these species are reacting, and then they form the product which is nitrogen dioxide, right? So let's quickly read. Word equation links together the name of the substance that reacts, okay? The species which reacts are reactants with those of the new substance which are formed, which are called products. The word equation for burning magnesium, okay. So the reaction is given to you. The word equation for burning magnesium and oxygen. So magnesium we will write plus oxygen, because burning of anything is always in the presence of oxygen. Okay, if you cut the supply of oxygen, there will be no burning taking place, right? So magnesium plus oxygen forms magnesium oxide. This is the word equation, right? In which magnesium and oxygen are reactants and the product which is formed is magnesium oxide. Next, the reaction between hydrogen and oxygen is another highly exothermic. Exothermic reaction means a lot of heat or energy is being given out while the reaction is taking place. Okay, the hydrogen and oxygen fuel cell is based on this reaction. The word equation is given. Okay, so we have already discussed how we will write the reaction for formation of water. Now quickly take a minute and write down the important points from this slide. Now let's try a few questions. Okay, so these questions are for you to try on your own, that we have to write word equation for the following reactions described. Okay, so I want you to take a minute here and try these questions on your own, then we'll discuss. So now let's begin. So iron rust because it reacts with oxygen in the air to form a compound called iron 3 oxide. Okay, so how do I write the word equation? So iron is being reacted, right? So iron, it reacts with oxygen. So oxygen gives a compound which is called iron 3 oxide. So simply we'll write this iron 3 oxide. Okay, it is forming iron 3 oxide. It means iron 3 oxide is a product, and we write the product to the right of the arrow. Okay, so we know that these are reactants. They react together to form a product. This is product, right? So this is your correct answer for the first question. Now let's move on to next. Sodium hydroxide neutralizes sulfuric acid to form sodium sulfate and water. Okay, it is a neutralization reaction. Let's try to write a word equation of this. Sodium hydroxide neutralizes sulfuric acid. So basically it reacts with sulfuric acid to form, it forms sodium sulfate and water. Okay, so this is going to be the word equation for B reaction. Now let's try C. Sodium reacts strongly with water to give a solution of sodium hydroxide, and hydrogen gases also given off. So sodium strongly reacts with water plus water gives a solution of sodium hydroxide plus hydrogen gas. Okay, plus hydrogen. Right, so this is going to be the correct answers for these questions. Quickly write it down. Now let's move on. Okay, so now let's discuss what are state symbols. So you must have seen in the equation, it is written in the bracket S, A, Q, L, or maybe G. Okay, so what does these symbols mean? So let's take one by one. S means solid. Okay, so this state symbol actually helps us to know that in what state of matter is that particular compound is present. Okay, so S means solid, L means liquid, G is gas, AQ is aqueous solution. It means when something is dissolved in water. Okay, that is known as aqueous. Okay, if I write Na, Na is a metal, it is solid, right? So I'll write S over here. If I have to write, let's say H2, so I can write G over here. It will describe that H2 is a gas which is formed. Okay, then if I have to write NaCl, okay, sodium chloride, it can be in solid state also, it can be powdered form also, it can also be a solution. So if I write AQ beneath NaCl, it means that we are talking about NaCl solution. It means that sodium chloride is in solution form. Okay, but if I write NaCl as S, it means that we are taking powdered form of NaCl, right? So this is what we call state symbols. Now let's talk about ionic equation. Now what are ions? Ions can be of two types, cation and anion. Cation is positively charged species, anion is negatively charged species. We all know that, right? So cation and anion. So here we have a simple equation. Let's check that how equations are formed. Okay, so basically in any equation, the simplified equation for a reaction involving ionic substances, only those ions which actually take part in the reaction are shown. Okay, so let's check. So if NaOH is reacting with H2SO4, I can say that NaOH is a combination of two ions, which is Na plus and OH minus, right? A compound is formed of two ions, a positive ion, negative ion. One gives electron, one takes electron. Another thing, H2SO4. I can write H2SO4 as H plus SO4 minus two ions, right? These are the ions which are present. Similarly, NaOH can be broken down into these ions, right? Now what happens, let me change the color of the pen. Now what happens, this cation combines with another compound's anion. Okay, so crisscross will be happening. This is known as double displacement reaction, in which one cation then reacts with another compound's anion. Okay, and what happens, the another compound's cation reacts with the first compound's anion. Okay, so the plus and minus charges actually crisscrosses to form new products, right? So the new product which I should get should be, so Na reacts with SO4 minus 2. Now one thing, that we will always write the cation species first and then the anionic species. Okay, or we will always write the positive species first and then at the end we will write the negative species. Okay, so what will be the products which we will get? Na plus will react with SO4 minus 2 and that will give me Na2SO4, right? plus what will be the another product? H plus is reacting with OH. So when H plus or hydrogen ions or maybe protons when react with hydroxide ions, it will give me water, H2O. Okay, and you can see here that the same products are formed, right? One thing is done, that how do we form reactions, how are products formed? By crisscrossing the cations and anion. This is also known as double displacement reaction. Another very important thing which you must have noticed is AQ. So basically AQ means I told you that this is aqueous solution. So NaOH is in aqueous state. Similarly, H2SO4 is in aqueous state. The product which we have got, which is a salt, sodium sulfate, this is also aqueous, and water is liquid. So this is L. Okay, water is liquid. Water cannot be aqueous, okay, because it is a universal solvent, it is liquid, right? So this is how we write a proper ionic equation. Make sure that you always check which all ions are present in a compound. Okay, for example, if I say, let's say MgSO4, okay, so this is actually composed of two ions, cation and anion. Okay, which is cation? Cation is always the species which is written first, this Mg, and which is anion? Anion is SO4 minus 2. Okay, this is a compound ion which we have studied, right? So any compound is a mixture of two ions, cation and anion. When we react two such compounds, then their cations and anions intercross, or maybe they undergo double displacement reaction or displacement reaction for that matter. Okay, and this is how we get products. So I hope this is clear. Now let's move on to balancing of ionic equation. So this is very important. Why do we have to balance any equation? To follow the law of conservation of mass. Now what is law of conservation of mass or law of conservation of energy? It states that mass can only be converted from one form to another. Okay, no atoms should be gained or lost during the reaction. Okay, the total mass of reactant and total mass of product should remain the same. For example, if I tell you that give me a sodium chloride solution, okay, or simply add water to or add sodium chloride or salt to water. So for example, you have NaCl. Okay, let's say you are taking 2 gram NaCl and water you are taking is 10 gram, for example. Okay, hypothetical example. Okay, so what will happen? You will add this, you will add the salt into water, and the solution you will get, it should be how much? It should be approximately 12 gram, right? Because otherwise where will the mass go? Right? Either it can convert into gas and you couldn't see it, but ideally it should be equal, right? Because where will the mass go or where will the mass come from? So it should not be greater or higher than 12 gram, it should be equal to 12 gram only, right? This is an ideal condition or ideal state. Similarly, law of conservation of mass also states the same thing. It states that the total mass of all the products of a chemical reaction is always equal to the total mass of all the reactants. Okay, this important law becomes clear if we consider what is happening to the atoms and molecules. So let's check. Involved in a reaction. During a chemical reaction, the atoms of one element are not changed into those of another element, nor do atoms disappear. Okay, where will they disappear, right? Or indeed appear from nowhere. A reaction involves the breaking of some bonds and forming of others. Okay, hence I can say that total relative molecular mass of reactant should always be equal to total mass of total relative molecular mass of that of product. Okay, so let's move on. Okay, so what is the balance equation for the reaction below? Okay, so let's try one question. Hydrogen oxygen reaction is given to you. So H is H2. We know that hydrogen is always present in the form of diatomic molecule for it to be stable. Okay, plus oxygen is O2. This will form H2O, right? Now here you can see, or you have to check that how many hydrogen atoms are present in reactant side and how many hydrogen atoms are present in the product side. Okay, so let's check. So in reactant side, hydrogen are 2 in number. In product side also hydrogen is 2 in number. What about oxygen? Oxygen is 2 in number, oxygen is 1. Okay, then where does this one oxygen atom go? It cannot go anywhere, because according to law of conservation of mass, the relative atomic masses or relative molecular masses of reactant side should always be equal to that of product side. Okay, or I can say that the number of atoms should remain same. So what do I do? And now I need to balance this reaction. So how do I balance this reaction? To bring this oxygen to, what do? I add a number over here. Okay, I will add a number over here 2. Now after adding this 2, I can say that the number of hydrogen has now become 2 times 2, which is 4, and number of oxygen has become 2, right? So this is your present state or number of hydrogen and oxygen. Now let's check here. How many hydrogen were there initially? 2, and oxygen 2. Let's put a 2 over here. Now what is the new state saying? Hydrogen are 4 in number and oxygen is 2 in number. Now you can say that the number of atoms are same in both reactant and product side. Hence I can say that this reaction has now become balanced. Okay, because no atom has gained or no atom has lost during the process of this reaction. Okay, so let me erase this part and let me show you the correct balanced reaction, which is right. So this is your correct balanced reaction. 2H2 plus O2 gives 2H2O. This is a balanced reaction. Okay, next one more example we have, carbon and oxygen. Okay, so when carbon reacts with oxygen, it will give me CO2, right? Carbon dioxide. Now let's check if this reaction is balanced or not. So 1 carbon is present here and 2 oxygen. Carbon is 1 in number, oxygen 2. What about here? Carbon 1, oxygen 2. I can say that this reaction is already balanced and I need not to balance this anymore, right? So this is these were the 2 examples. Let's take one more. Okay, let's take one more. For example, you have magnesium. For example, you have magnesium. Okay, you burn it in air in the presence of oxygen and you get what? You get magnesium oxide. Now I ask you to balance this reaction. First you need to check if the reaction is already balanced or not. So how many magnesium atoms you can see? 1. How many oxygen atoms you can see? 2. Here how many magnesium atoms? 1. How many oxygen? 1. Okay, so first we need to balance oxygen atoms. So remember one thing, we can never add a number at the subscript. Okay, the subscript number should not be added by us. We can only add a number as a stoichiometry like here. Okay, so 2 I am adding there to make my oxygen number 2. But because of me adding 2 over there, magnesium number has also raised by 1. Okay, so to increase magnesium over here, I will add 2 over here also. Okay, now let's check. Let me change the color. Let's take this one. Okay, now how many magnesium are present? 2. How many oxygen present? 2. How many magnesium present? 2. And how many oxygen present? 2. Okay, because this will be for both of the atoms, right? So this is how we are going to balance any reaction. Quickly take a minute and write down these things. Now let's move on to your next slide. Okay, so there are few questions for you. Balance the following symbol equations. Okay, so symbols are not given, but yes, we have equations. Let's try to balance them. So Cu plus O2 gives 2Cu. Okay, so here you can see that 2 oxygen are present, but in the product side only 1 oxygen is present, right? So I can add a 2 over here. By adding a 2, I am also increasing the number of copper atoms. So I can add a 2 right here also. Now this reaction is balanced. Okay, next let's check. N2 reacting with H2 gives NH3. Okay, so here ammonia is being formed. Let me change the color of the pen. Okay, so how many nitrogen atoms can you see over here? 2, right? In total 2 nitrogen atoms are there. Here you can see only 1, so let me add a 2 over here. Now how many hydrogens do I have in the product side? Simply 2 times 3, which is 6. Okay, so to make this hydrogen 6, what do? I add a 3 over here. Okay, now 3 times 2 is 6. Now this reaction is balanced. Now let's check another. So sodium is being reacted with oxygen to give Na2O. Now let's check. Here you can see 2 oxygen are there, right? 2 oxygen atom in the reactant side, but in product side only 1 oxygen you can see. So let's make it 2. By making this or by balancing this oxygen, I'm also increasing or altering the number of sodium. Okay, so this now becomes 2 times 2, which is 4. So let me add 4 over here, right? Next is your neutralization reaction, in which base and acid is being reacted to form salt and water. Let's check. Okay, so how many sodium you can see here? 2 sodium. And what about in reactant side? Only 1 sodium I can see. So let's add a 2 over here. Okay, now how many hydrogen atoms? Okay, so 2 from here and 2 from here, which is in total in reactant side hydrogen atoms are 4 in number. Okay, and what about in product side? Only 2. So to make this 4, what do? I simply add 2 over here. Now let's check the total number of reactant in the reactant side. Let me write R over here and P. Right, so in reactant side total number of sodium atoms are 2, in product side also 2, right? In reactant side oxygen is 2 plus 4, which is 6. So oxygen is 6. In product side 4 plus, this is 2 only, 4 plus 2, 6. Yes, this is also balanced. Next is your hydrogen. 2 plus 2, which is 4. Hydrogen are 4 in number. And over here also hydrogen is 4 in number. Okay, yes, I can say that this reaction is balanced. You always have to check after balancing the reaction that if any atom is unbalanced or not. Okay, now let's move on. Let's move on to your E part. Aluminium and Cl2 reaction is given to you. Okay, so AlCl3. Okay, what do I do now? Let's try hit and trial method, right? Let me put a 2 over here. By adding a 2 over here, I have made my aluminium atom as 2 in number, right? So let me add a 2 this side also, in the reactant side also. Aluminium is now balanced. Let's talk about Cl. So 2 times 3 is 6. To make this Cl2 6, I will simply add 3 over here. Right, so 3 times 2 is also 6. So now aluminium is 2 in number, both in reactant and product side, and chlorine atoms are 6 in number, both in reactant and product side. Now let's move on to your next reaction. Okay, so before we move on to your next reaction, I would like you to pause this video here and try F and G by yourself, and then we'll come back. Then I'll come back and then we'll discuss. Okay, and if you have any doubt, make sure you comment down below. I will get back to you. So quickly take a minute and try F and G on your own. I hope you have tried these questions. Now let's discuss one by one. So F part, in this, how many iron atoms you can see? In the product side, you can see 3 iron atoms. So to balance this, I will add a 3 over here. Okay, next is let's check your hydrogen atom. So what if I add a 2 over here? If I add a 2 here, then the hydrogen, to balance this hydrogen, this will become 4, and okay, not 4, 2, right? To balance the hydrogen, this will become 2, right? But because I have added a 2 over here, this has also changed the number of oxygen atom, right? Because in the product side, you can see oxygen atom is 4. To make this oxygen 4, what do? I will add a 4 over here, and to balance the hydrogen, now I have to add a 4 this side also. Okay, now let's check. 3 iron in reactant side, 3 iron in product side. How many oxygen in product side? 4. And in the product side, 4. Yes. Then hydrogen 4 times 2, which is 8 in the product side. And here 4 times 2, which is 8 in the reactant side. So hence we can say that our reaction is balanced. Always make sure that you recheck your reaction if it is balanced or not. Now let's move on to your G part. Let me change the color of the pen so that we do not get confused. Okay, so here how many carbon do you see? In the reactant side, there are 3 carbon atom, right? So to make this carbon 3, I add a 3 over here. Now how many oxygen are present here? 3 times 2, which is 6. But over here also we have hydrogen. So how many hydrogen in the reactant side? 8. To balance the number of hydrogen in the product side, I add a 4 over here. So 4 times 2 become 8. Now how many oxygen in total? 4 oxygen here and 3 times 2, which is 6 oxygen here. So in total 10 oxygen atoms should be there in the reactant side. Okay, so to make this 10, what do? I add a 5 over here, right? So the balanced reaction will become C3H8 plus 5O2 gives 3CO2 plus 4H2O. Okay, always recheck if the reaction you have balanced is correct or not. Okay, so 3 carbon in the reactant side, 3 carbon in the product side. In the reactant side, 10 oxygen. In the product side, 10 oxygen and 8 hydrogen in the reactant side, 8 hydrogen in the product side. I hope this is clear. Take a minute, write this thing down. Okay, now few more questions and then we'll end this lecture. So change these word equations into balanced symbol equation. So word equations are given to you and we have to change it into symbol equation and then we need to balance this, right? So let's quickly do this. Hydrogen plus chlorine gives hydrogen chloride. So hydrogen is H2 plus chlorine is Cl2 gives hydrogen chloride. Now how do I deduce the formula of hydrogen chloride? The same way, HCl, then we write the valency is 1 and chlorine is also 1, then we crisscross this. This will give you HCl, okay? So HCl. Now let's try to balance this reaction. How many hydrogens do you see in the reactant side? 2. So to make this hydrogen 2, I added 2 over here. And now let's check how many chlorine are there in the reactant side? 2. And here also there are 2 chlorine atoms which are present. So hence we have balanced this reaction. Now next let's move on to your B part of this question, wherein copper is reacting with oxygen to form copper oxide, right? So copper is Cu plus oxygen is O2 forming copper oxide. Now how do I deduce the formula for copper oxide? Cu and O, okay? Oxygen valency is 2, copper valency we consider it to be 1 because there is no valency given in the bracket, so we will consider it to be 1, okay? Then we crisscross this. This will give me Cu2O, right? So this will become Cu2O. Now let's quickly balance this. How many copper in the reactant side? 1. In product side 2. So let's make it 2. Now how many oxygen? 2. Over here only 1. So I will add a 2 over here. After adding 2 over here, I will observe that now the copper number have also increased, right? So now copper are present in the product side, which is 2 times 2, which is 4. So I will erase this 2. This is hit and trial method, okay? And then I'll add a 4 over here. Now I can see that the reaction is balanced. Okay, 4 Cu plus O2 gives 2 Cu2O. Correct? I hope this is clear. Next, let's move on. Okay, let's take one more part of the same question. What if we consider the valency of copper to be plus 2? Okay, because copper can be present in plus 1 and plus 2 oxidation state. So if we consider valency of copper to be 2, then it will become, if we will crisscross, this will become CuO. Okay, then how will I write the reaction? Then I will write the reaction like this: Cu plus O2 gives CuO. The only difference is, in the first case we are considering, this is case number 1, here we are considering copper valency to be 1 and here we are considering copper valency to be 2. Okay, this is case 2. You can take any, whichever you want. So now let's balance this. We'll add a 2 over here and we'll add a 2 over here. This becomes your balanced symbol equation of copper reacting with oxygen to form copper oxide. Next is your, okay, next is your C part, magnesium plus zinc chloride. Now let's try to write down. Magnesium is Mg plus zinc chloride is ZnCl2, right? It will give magnesium chloride plus zinc. So how will I deduce the formula for magnesium chloride? Mg and Cl. Mg valency is 2, Cl is 1. We'll crisscross and this will give me MgCl2. MgCl2 plus Zn. Okay, this will be the reaction. Now let's try to balance this. So how many magnesium in the reactant side? 1. How many magnesium in the product side? 1. How many chlorine? 2. And how many chlorine? 2 and Zn. This is already balanced. We don't need to write any number, any stoichiometry. We don't need to add. It is already a balanced reaction, right? Quickly take a minute and write this thing down. Okay, so here we come to an end of your part 2 of stoichiometry. I hope this is clear. If you have any doubt, feel free to comment down below. I'll get back to you. And keep watching. We will be coming soon with the third part of stoichiometry. That is going to be very important. So till then, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.